Working Safely in Cornell Laboratories. Brought to you by the Cornell University, Department of Environmental Health and Safety. To complete this course, you must view all of the slides and receive a score of 80% or more on the quiz. The bar at the bottom of the screen will enable you to move back and forward in the tutorial. You can pause the tutorial or rewind to the beginning of a slide. To mute the tutorial, click here and here to exit. Introduction. Laboratory science in the 21st century is changing rapidly, as the science becomes increasingly innovative and multidisciplinary. In this environment, maintaining the safety of laboratory workers and the community as a whole requires ongoing attention and management. This is achieved through a partnership between laboratory workers, academic departments, and the EH&S department, working together to carry out programs such as worker training, laboratory waste disposal, and emergency planning. The goals of today's program are: identify laboratory hazards and how they are managed, review lab safety resources at Cornell, outline government regulations and how they apply to your work, fulfill basic OSHA training requirements for people working in labs where hazardous chemicals are used. This training is for people who work in Cornell laboratories, have some understanding of the science they want to do, and will be supervised while working in the laboratory. This program does not discuss how to manage biological, mechanical or radiation hazards, reviews safety protocols for specific chemicals, or identify how chemicals and other hazards, biological, radiation or nanomaterials, interact in potentially hazardous ways. For information about these concerns, you should take more specific training, ask for help from other people in your lab, or use the Ask EHS web page to ask us for help. To help you prepare for the test at the end of this course, practice questions and activities are provided as you go through the course. You will need to complete these activities before the course will resume playing. What is environmental health and safety? Beyond the department, EH&S is a shared responsibility that consists of 4 key priorities. They are: the safety and health of the campus community, complying with government regulations, promoting laboratory productivity and providing a laboratory safety education. What is a laboratory? According to OSHA, a lab is a workplace that manages chemical hazards by using quantities small enough to be handled by one person. Generic safety equipment, such as ventilation systems, eye protection, gloves and lab coats. Oversight of an educated workforce, and plans for foreseeable emergencies. There are many kinds of hazards in Cornell's more than 3,000 laboratories. These include chemical, biological, mechanical, electrical, and radiation hazards. This slide gives you an idea of the different combinations of hazards found in Cornell laboratories. Your lab will have a unique combination of these hazards, which will require a specific management plan. This management plan must address specific government regulations. A variety of government agencies regulate laboratory safety issues. For example, chemical hazards are regulated by OSHA, the Occupational Safety and Health Administration, which tracks chemical hazards to lab employees, and the Environmental Protection Agency, which tracks chemical hazards to the environment. There are many agencies that impact biohazard management. Depending on what you're working with, a variety of agencies may be involved in reviewing your lab practices. Radiation hazards are tracked by the Nuclear Regulatory Commission. Regulatory compliance at Cornell. Cornell has developed a variety of support programs to help laboratories comply with these regulatory requirements. These programs are described on the EH&S website. For specific regulatory questions, submit your question to the Ask EHS system to have them answered by the correct expert. Many departments on the Cornell campus have appointed Departmental Safety Representatives, DSRs, to serve as safety resources for their staff. In this role, they can assist in safe workplace management, coordinate departmental safety efforts, arrange assistance from EH&S for specific concerns, and coordinate follow-up to EH&S lab inspections. Drag and drop the logo of the regulatory agency to the sign for the hazard it regulates.
Great job! To support lab safety efforts on a diverse campus, we have developed the Cornell Lab Safety System. It has 6 key elements: awareness of lab health and safety issues, hazard identification, risk assessment, safety management, training and oversight, emergency preparedness, and laboratory sustainability. Awareness of lab health and safety issues. Being aware of laboratory health and safety hazards, Cornell's laboratory safety system, and the reasons for the university's interest in your safety as you do your science, is an essential part of the laboratory safety culture at Cornell. Let's briefly look at 2 seminal cases in the history of laboratory safety, specifically those involving radium and plutonium handling practices. Radium was discovered in 1898 by Pierre and Marie Curie. They won a Nobel Prize for this discovery in 1903. After years of handling radium in the laboratory, Marie died in 1934 from radiation exposure. Her notebooks are still too radioactive to handle without protective equipment. Another group exposed to radium were the Radium Girls from New Jersey. These girls painted glowing watch dials at the United States Radium Factory between 1910 and 1920. They were told that the radium they were using was harmless. They ingested radium by licking their brushes to sharpen them and even painted their nails and teeth with the glowing substance. Many suffered from anemia and bone fractures of the jaw, or radium jaw. Glenn Seaborg went to college in the 1930s where he heard of the Radium Girls. He won a Nobel Prize in 1951 for discovering plutonium. When he became responsible for running the lab that purified plutonium for the Manhattan Project, he initiated lab safety practices for its safe handling. Seaborg's guidelines included smooth floors and walls to allow for effective cleaning, cleaning the lab twice a day, air monitoring for toxic chemicals, a maximum of 4 people per lab group, no eating, drinking or smoking in the lab. This is the origin of many of today's standard lab practices. The result of these lab safety practices was that a 1990s health study found that plutonium lab workers lived slightly longer, healthier lives than their peers on the project. Dr. Seaborg's environmental health and safety initiatives were credited for this.
Roll over each answer to the sample questions to find the correct one.
Hazard identification. Labeling is an important part of hazard identification. Laboratory labels are our system of communication. The audience for chemical labels includes people working both inside and outside the lab. Unknown chemicals are a danger to everyone who has to handle them. Cornell, the Hazard Assessment and Signage Program, is used to identify lab hazards on a room-by-room basis for visitors and emergency responders. Signs are posted at room entry, and also include room contact information. Chemicals are materials that retain their properties as they change their shape. Chemicals are the most common laboratory hazards and have their own system of labels and signs to help you identify their hazards. The globally harmonized system is the international set of hazard definitions and labels, defined by the United Nations and taking effect in the U.S. in 2014. The GHS defines 9 types of chemical hazards. They are flammables, oxidizers, explosives, compressed gases, corrosives, acutely toxic chemicals, health hazards and carcinogens, irritants, and environmental toxins. The GHS also defines 2 signal words to indicate the severity of the hazard. These signal words are danger and warning. Included in the GHS are specific definitions of the hazard words. One example is flammability, which is based on flash point and boiling point. The safety data sheet identifies unusual chemical hazards and provides specific health information such as signs and symptoms associated with exposure to the chemical. It also identifies any applicable government standards. The information in an SDS applies to a specific chemical, not reactions between chemicals that you may be using. Further risk assessment is necessary to prepare for the hazards of chemical reactions. Groups of compatible samples can be stored together in a secondary container. When labeling these samples, the label must include the name of the person to contact for information about the materials, as well as the chemical name, concentrations of each chemical, hazards associated with the chemicals and the date the material was made. Groups of compatible chemicals and samples can be stored together in a secondary container. Be sure to post a key if abbreviations are used in their labeling.
Roll over each answer to the sample question to find the correct one.
Assessing risks and managing hazards. In addition to the hazards associated with the use of common laboratory chemicals such as solvents, acids and bases, specific chemicals may have unusual hazards, such as being pyrophoric, or reacting with air to cause fire, being water reactive, or exploding on contact with water, being flammable or toxic, causing explosive reactions, or being carcinogenic. If you are not sure how to use a chemical safely, ask your laboratory supervisor or use the Ask EHS webpage to find the person who can best help you assess these unusual risks. Because every laboratory works with a different set of hazards, more specific safety information about your lab work will be provided by your laboratory supervisor. Questions you should be able to answer include: which laboratory work should be done in a fume hood or a biosafety cabinet? When and where and what type of PPE must be worn in the lab? Who should I report an accident to? And who should I ask for help with further questions? The resources listed here contain useful safety information and are available on the web. If you still have safety questions after reviewing these resources, we will be glad to help you answer them. Contact us via the Ask EHS webpage. As Dr. Seaborg realized, laboratory housekeeping is a key element in maintaining a safe lab. Everyone in a lab group must work together to keep the work area uncluttered, store chemicals in secondary containment, clean up drips and spills as they happen, and wipe down your work area at the end of the day. Flammable liquids need special chemical storage to be protected from the possibility of a fire in the lab. Cooling flammable chemicals also requires a laboratory refrigerator to control fire and explosion hazards. This household refrigerator was being used to store a flammable liquid. The cabinet filled with vapors and exploded when the switch in the refrigerator activated, causing a spark. Hazard assessment is an important step in use of personal protective equipment. It identifies the hazards associated with a defined task and prescribes personal protective equipment and other relevant protection measures that must be employed to reduce risks from these hazards. The risk assessment will help you match your gloves, lab coats and eye protection to the hazard you are exposed to, as well as assuring you have the right size of each. For example, protecting your hands from oil-soluble chemicals requires gloves which fit well and are made of materials impermeable to those chemicals. Consult the PPE manufacturer or ask EHS for information on specific equipment.
Roll over each answer to the sample question to find the correct one.
Emergency preparedness. In 2011, Google reported 148 laboratory hazmat responses in the U.S. This is about 3 per week. Over half of these were to labs in higher education, 45% were in research labs, 10% in teaching labs. In these responses, 1/3 of the time someone was hurt, one person died immediately from an explosion in an industrial laboratory. These numbers clearly identify the importance of planning for emergencies in laboratories. In case of an emergency, the key steps to a good response are: 1. Be prepared, know the hazards before the emergency. 2. Recognize the emergency. 3. Protect yourself and others. 4. Assess the situation. 5. Arrange to fix the problem. 6. Review lessons learned, and plan recovery. If you are contaminated by a chemical splash or other release, do not hesitate to use an eye wash, safety shower, or drench hose to wash the affected area. At the same time, ask someone to call for help so that you can be medically evaluated for any potential health impact from this exposure. If you would like more detailed training on emergency management and first aid, contact EHS and we'll be happy to arrange a training for your lab.
Roll over each answer to the sample question to find the correct one.
Laboratory sustainability. For Cornell to be able to support laboratory research throughout the 21st century, we must begin to move our laboratory practices in more sustainable directions. Specific issues of concern in this regard are laboratory waste management, energy conservation, and green chemistry and green nano. Disposal of chemical waste requires that Cornell EH&S staff pick up, clean, properly labeled chemical containers from laboratories. The containers are transported to our waste facility, where they are sorted to be commingled, or sent out as is. The waste handlers depend on lab workers to do their part by labeling wastes and keeping containers clean for everyone's safety. There are many other kinds of waste materials generated in Cornell laboratories, including sharps, materials contaminated with biohazards, blood and body tissues, radioactive wastes, and mixed wastes. Disposal of each of these requires specific procedures to protect lab workers, waste handlers, and the environment. Visit our website to access the waste disposal guidance documents. At Cornell, laboratories consume about half of campus energy, primarily due to ventilation requirements. Each fume hood uses the equivalent of about 3 homes of energy to heat and cool. There are over 1,700 fume hoods at Cornell. To keep yourself safe and save energy, lower your fume hood sash. There is increasing interest in identifying and controlling the hazards of new materials as they are being developed. This research is generically called green chemistry and green nano. The EPA and American Chemical Society are partnering through the Green Chemistry Institute to support green chemistry. Similar efforts are underway for engineered nanoparticles, for example, in the Safer Nanomaterials and Nanomanufacturing Initiative.
Roll over each answer to the sample question to find the correct one. Timothy Gallagher of the Chemistry Department at the University of Bristol provides this reminder about laboratory safety. You always look both ways before you cross the street, even if you've crossed that street safely 100 times before. Take the same approach with your lab experiments. The information in this course provides an overview of how to work safely in Cornell laboratories, but it does not provide the complete information you'll need. Cornell EH&S provides a variety of more specific trainings about safe laboratory practices. Some of these are required by regulations. Others discuss best practices for specific laboratory hazards. Your lab's supervisor will provide further training specific to the work you will be doing. Be sure to ask them any safety-related questions that arise as your work proceeds. If you have any follow-up questions about topics that have been covered, use the Ask EHS webpage at the address below. Your question will be directed to a knowledgeable expert.
Working safely in Cornell laboratories. When taking the quiz, press Submit to enter your answers. If the answer is incorrect, you will get the correct answer immediately. To complete the course, you must receive a score of 80% or more on the quiz. If the course is not shown as complete, it will need to be repeated.
When you are ready, click the button to start the quiz. Thank you for viewing, working safely in Cornell laboratories, and completing the quiz. If you have not passed the quiz, please retake it. If you have passed the quiz, please exit the tutorial and make sure that the course registers as completed in CU Learn.